Okay, it looks like it's starting to stabilize. So we'll get started, and as people filter in, they can join as we do that. So welcome to this webinar on unlocking the power of geospatial data. My name's Dr. Alfred Tiley. I'm a data scientist at the Data Lab. Obviously, this event is hosted by the Data Lab community. Today we're going to be focusing on geospatial data, which is all around us. It's used for things like navigation apps, delivery tracking, weather forecasting, mobile location services, fitness tracking, and many other areas. We have a panel of experts in geospatial data with us today, and I'll introduce them in a second. Today we'd like to talk about geospatial data, what they do with it, and what they're working on, but also for organizations that are looking to make use of geospatial data, we'd kind of like to cover what kind of challenges there are in using this type of data, complexity, cost, skill level, and interpreting and deriving insights from the data as well. So it should be a good discussion. We have with us today Professor Anna Basiri, who's a professor of geospatial data science at the University of Glasgow, James Reed, who's head of services at Adena, Richard Harris, who's co-founder and CEO at Intelligent Reality Limited, Nikki Potts, who's a data scientist at the Office for National Statistics, and Simon Roberts, who's a data and engagement manager at Improvement Service. So the way today is going to work is we're going to have a round of 4-minute lightning talks from each of our panelists, where they're going to tell us about their work in geospatial data. And then afterwards, we'll have a panel discussion for about 45 minutes, where I'll pose some questions to the panelists and they can discuss geospatial data. And then we'll have time for Q&A at the end for about 10 minutes or so. So if you have questions during the webinar, put them into the Q&A and we'll try and cover as many as we can at the end. So we'll start off with the lightning talks, and kicking us off, if we ask Professor Anna Basiri, if you'd like to share your screen, Anna, and then I'll be trying to be keeping you all strictly to 4 minutes time if I can. So I'll start a timer once you're ready. So we'll just wait for your screen to come up.
Okay, can you see that now?
Not yet. Not yet.
Sorry, if we practice this, I apologize.
There's a slight delay, but maybe if we try again, we can always.
Okay, yeah, sometimes it happens.
If not, we can come back to you, Anna. Oh, there we go. It's loading now.
Okay, great. Yeah, perfect. I hope you see this. I try to be as brief as possible to compensate.
So it's just loading. I'll say when I can see it. There we go. We can see it, but it's not in presenter mode at the moment. It's the whole PowerPoint.
Okay, I'll start. I think I see it in PowerPoint presentation mode. Hopefully that come to you in a few seconds time. Otherwise, you see my default sections too. So I have a mission impossible to talk about even less than 4 minutes about what our team in Geospatial Data Science Research Group at the University of Glasgow does. And then I very briefly go through the bigger picture that we have as a part of all the activities related to that. And very, very briefly, I will talk about the challenges and opportunities. We believe we live in the time that is very fast changing. And if we want to respond by a data-driven policy in a timely manner, we need some data that is a little beyond just surveys and interviews, that sort of new form of data like mobile phone data and card transactions, the smartwatches and so on. They are great because they update the society and city on a very fast changing rate, but they have biases and missingness issues. So my team work basically on these sort of theoretical but also applied solutions that look at the balance between new forms of data and traditional data. And of course, one of the good things that we do as a part of our team is looking at missing data as a useful thing. So I just picked one of the work that we do in order to be brief and tell you how missing data could be useful. For example, one of our projects is to create 3D maps of city from where you get your GPS blocked. I know where the GPS satellites are. I know where I am. If I don't receive the signal, that means there is a building between me and satellite. So I can estimate the height of the building when it comes to my view. Sometimes even signal comes through windows or bounce off from the building. So I can estimate the facade of the building or even the type of material it has gone through. So that's a very good physical example of how missing data can actually be useful data. The other example is human data. For example, whenever you say, I prefer not to declare my income or how many pints of beer I had last night, you don't say it because the number is either very large or very little that you're embarrassed. So these sort of not declaring something is something that may mean something. So we are looking at, for example, the transportation data that comes from NTS, National Travel Survey, to understand if they actually mean something. So we compare the average income with the one who didn't say that on aggregated level, of course, to understand if there is any correlation. So this is one of the examples. Of course, there are a lot of ethical privacy and perception of at least the invasion of the privacy exists. So we are also dealing with that in some part of our work. We work with others because we believe, okay, we talk about a lot of methods that are developed, statistical or even other technology that are ready, but we need to look at social readiness as well as technology readiness level, as well as the policy readiness level. So we work very closely with government and the decision maker. And of course, we work a lot with the skill development, so a lot of training courses, the kind of models that we have for STEM ambassadors and celebrity scientists. That is enabled by another role that I have, which is I am the director of Center for Data Science and AI, that we try to promote these sort of initiatives that are at the moment a bit of a challenging. So I just wanted to thank our funders and of course whoever helped me to get through to this position to talk to you in less than 4 minutes about what they have done. Thank you.
Brilliant, thank you, Anna. That was with time to spare, so very impressive. That was a great talk. We'll hopefully have time to come back to some of those points in the discussion. So we're going to move over to James now, if you'd like to share your screen and start your talk.
Sure, thanks, Alfie. So hopefully folks can see that.
I can see it.
Okay, well, I'll assume others can see it as well then. So hi, everyone. My name's James Reid. I'm Head of Services at EDINA at the University of Edinburgh. EDINA is formerly part of the Information Services Group, the computing services part of the University of Edinburgh. We've been around since 1996, and essentially what we do is develop ed tech solutions to drive the sector to assist in teaching and research. We are internally kind of the university's in-house tech innovation hub. Hopefully some of you on the call will know us from our flagship services, Digimap and Digimap for Schools. Effectively, what we do is act as a kind of central broker with data suppliers to barter deals on behalf of the academic community that gives access to those data sources. So on the right-hand side there, you can see a bunch of our current data suppliers. That's ever growing, and we're always open to requests for new forms of data and sourcing that on behalf of the community. We currently run Digimap to about 100,000 users across 127 of the UK universities and about 75 colleges. We have our sister service, which is a simplified version of Digimap that doesn't provide access to data, just does mapping. That's for primary and secondary kids. We currently have about 4,900 schools with approximately 500,000 user base. We develop our applications in a kind of agile fashion in a kind of robust cloud environment. We provide online support and a secure hosting and monitoring, which is something the data providers are always quite keen on that we do. One of the other services that we've recently, in the last few years, pushed out is a computational notebook service called Notable, which has pre-prepared programming environments. And one of those is specifically geospatial. So if you want to teach in your lectures and you need geospatial packages, that's all pre-done. That's heavily used within the University of Edinburgh itself. We have it across about 7 other higher education institutions and a couple of European research institutes who use it. We also provide managed access to data through that platform. Currently, that notable service, as I say, is kind of still in rollout mode, but it is something that will provide a computational environment for higher education as well as for schools. So currently, if all schools in Scotland have access to Notable through Glow, and an interesting metric from that is the most heavily used kind of computational platform across Scottish schools is actually RStudio. We also do in Edina some development work and project and consultancy work. For those of you that have ever visited a beach in East Lothian, there's an app on the App Store called Visit East Lothian. That is something we developed with a kind of Esri toolkit and colleagues in the university with a kind of IoT background. So we have IoT sensors in all the beaches across East Lothian that reports real-time car capacity. So if you know if you're headed on a sunny day, which beach to avoid and which one to go to because you get parked. Those are the sorts of things we do. We're currently working with the University of Cambridge on a smart campus solution for them. And I'll probably stop at that, and I'm very happy to answer questions after the session.
Brilliant. Thank you very much, James. That was also perfectly to time, so appreciate that. Some really interesting work that you're doing in Edina. Hope to unpack that a little bit. We'll move on to Richard now for Richard's talk. If you'd like to share your slides, Richard.
Right, are they coming through all right?
They are, yes. So
Right,
whenever
excellent.
you're ready.
Right, thank you very much, Alfie. Right, I'll be slightly contentious here and say that we're coming from the background of saying that the use of geospatial data is rather in the pre-industrial era. In other words, pre-industrialization, we had lots of different systems that weren't tied together. They were function specific. They required specialists to use them, and analysis tends to be handcrafted, manually driven, and of course needs to be redone every time you move to somewhere else or try and look for a pattern across the landscape. So what we've done is start with the belief that to truly unlock the power of geospatial data, we do need to be able to integrate diverse data sources to then reinforce, complement, contradict, and qualify each other, where each adds to the truth model for an area, an activity, or a process. We need to do so within a common framework, which allows exploration, discovery, forecasting, and monitoring without making any assumptions about the application or the area that it's being applied to. For the challenges that we are addressing, particularly those environmental degradation and planning for mitigation and adaptation around climate change, we need to democratize access by ensuring that non-specialist end users can use the systems effectively and interactively by providing the tools that get the GIS team out of the critical path and into the background where they can be assuring quality and updates in the background rather than being a bottleneck in the system. So we've created a tool called Blue Globe, designed to do exactly that, and that's as much sales pitch as you get from me. I'm just going to talk through a little about what's at its heart. What we've done is we take multiple diverse data sources, and that's everything from satellite data, from multiple sources at multiple resolutions, OpenStreetMap data, the ONS demographic data. We've brought in a massive amount of COVID data when we were working on that. So what we're doing is we're creating a common multi-resolutional computational model for Earth, from which we can create and display a geospatial datascape by any combination of parameters. We use smart data importers to get the information into the system and refresh it. And then we've got the tools of analytics and visualization that enable you to explore, discover, analyze, and visualize in real time. So we're building a library of standard analytics. We've got the tools to allow people to roll their own, bring up any combination they like. This gets us around the problem we have with things like ArcGIS or any mapping system where you've got multiple layers, and by the time you've got 3 or 4 switched on, you've no idea what's happening in the system. We work with a combination of human interactive systems and our own AIs working in the background there. So the idea is to create something that addresses specific applications. So everything from, as I say, climate adaptation mitigation, agriculture and forestry. So for instance, we've got a model that actually helps wine producers work out where, with a changing climate, where are going to be good places to buy land and invest over the next 10 to 30 years. We've got environmental monitoring and forecasting, discovery for nature networks, helping prioritize 30 by 30 initiatives, helping companies with their ESG policy formulation. All of those are all based on the same core models that all sit together. And so what it looks like, in short, and I'm just about out of time, that's actually Madagascar. You can start with a course model. That's it. That's a visualization. That's actually a topographic visualization. It's not a map. This is recreated from our computational model. And then you've got a much finer grained one in the background there. We can produce reports. We can pick anything across the landscape. We can work from parameters. We can work from examples. For instance, we've used it to discover rainforest candidate areas across Scotland. Whereas the Nature Scot project took something like 18 months to identify 120 existing areas down the west coast, we can actually run the whole of Scotland now in 8 seconds. So that's the sort of advantages we can get from that. We can walk across the landscape. We can do interrogate multiple data sets in real time against a common framework. Thank you very much.
Thanks, Richard. Really interesting there, and some really interesting points about kind of democratizing access and how you can deal with kind of different siloed sources of data. So hopefully we'll touch on that in the discussion. Moving on, we'll have Nikki's talk next. So Nikki, if you'd like to share, oh, you've already shared a slide, so one step ahead of me. Go ahead when you're ready.
Thanks, Alfie. So I'm Nikki. I'm a data scientist in something called the Data Science Campus, which is part of the Office of National Statistics. And I work in a team specifically looking at international development. So the UK has a commitment to spend 0.5% of gross national income to support international development. And one of the ways the UK government does this is by providing support and expertise. And that's one of the ways that our team come in. So we do things like we mentor national stats officers, and we also work on data science projects in which we might be able to provide novel solutions in areas where traditional data sources can't be applied. One of the ways in which we do this is through Earth observation and data science. So we've done a couple of projects in our team where we've been detecting trucks in East Africa. Probably the one that gets the most attention is counting cows in South Sudan, but we've also looked at reforestation in Uganda. I'm just going to very briefly give you kind of an overview on a project that we're currently working on to give you a bit of a sense of what we're doing and why. So we're currently working to support a census in Somalia. The last credible census in Somalia was in 1975, but there is a commitment to having one next year. And that's through the Somali government, but also international partners such as UN agencies and also other countries. One of the kind of issues or one of the problems that they have in doing a census in Somalia is that there are a lot of internally displaced people. So these are people who've been forced to leave their homes, but have not crossed an internationally recognized state border. So there's estimated about 2.9, but actually estimates go up to 4 million people who've been displaced in Somalia. And they tend to live in tents on the outskirts of towns, and they can be very dynamic, these camps. They change quite a lot. Some of them are on floodplains, some of them have had populations that have stayed because of the ongoing drought, and also because they're on private lands, there tends to be some clearing as well. Because also some of these can be in areas with ongoing conflict, so it's difficult to send people on the ground and it's difficult to look at historic images. So for someone to come in and take Earth observation data, so satellite imagery, and manually count all these buildings is really, really time intensive. So it takes effectively a couple of years of 1 or 2 full-time people to do this. And as I say, as these camps are so dynamic, it means by the time that they provide the estimates, they're actually out of date. So what we are doing at the campus is seeing if we can develop a machine learning model. So we're actually doing deep learning. We're using something called UNet to detect structures in these what we call IDP camps. And we want to do this to a high degree of accuracy. One of the things that's really important in the work that we do is to make sure that this actually is a resource saving So if we create a model, we need to make sure that actually running our model takes less time than having someone manually do it, because we need to make sure that we are cost effective. So we've been using Planet SkySat imagery, which is a resolution of 0.5 meter per pixel, and which we can use our model to pick out tents and buildings that make up these IDP camps. And the hope is that this work will then feed into census preparations, so that we were able to come up with enumeration areas, which makes the having a census more realistic. So that is our work in a nutshell.
Brilliant. Thank you very much, Nikki. So last but not least is Simon. Simon, if you'd like to share your screen. Some really interesting points covered there, Nikki. I'd like to come back to a couple of them, particularly on the work internationally and the implications of geospatial data there. But for now, we'll let Simon start. So whenever you're ready, Simon.
Can you see that okay?
Yes, can see it perfectly.
Thanks, Alfie. So yeah, I'm Simon Roberts. I'm a data engagement manager at the Improvement Service at the moment, but I previously worked as a civil servant within DEFRA and communities and local government. And I just want to tell you about how our world of geospatial relates to the wider data world. So the Improvement Service is a not-for-profit company that's actually owned by the 32 local authorities in Scotland, and we exist to basically work alongside local government on improving their public services. But our basic problem when we're looking at spatial data within our team relates back to the way that policy is created in this country, both at Scottish level and UK level. Policy is often created about the what without the how. And our journey really began with this first statement here, which is all about the responsibility for address and street creation in Scotland. And it's those final 4 words are the big problem, as they see fit. You have 32 autonomous organizations who are going to create their own solutions. So if you want a national perspective of what's going on, it's incredibly difficult to get that. And the more you start digging, the more you see these sorts of wordings in all of the policy that's created, and it causes an immense amount of confusion. And effectively, we're left with a jigsaw puzzle of data that somebody has to come along and sort out. So that's what we're trying to do. But luckily, we have certain data principles that can guide us in this endeavor. And hopefully most of you will be aware of the FAIR principles. Often people put a Q in front of that, Q FAIR. And in the geospatial world, we've really had a head start on these sorts of things. 15 years ago, we had an EU policy called Inspire legislation. It was written in Scottish law and into UK law. And Inspire focused on those 2 parts of the FAIR principles that I've circled there: findability and accessibility. So we've been doing this in the geospatial world for 15 years now. And really what we've built is a sort of connected ecosystem of metadata records, which is the discovery part of Inspire, and also accessible services like view services and download services in the Spatial Hub product that we've created. So the Scottish Government have created a site called spatialdata.gov.scot. That's built on an open source technology called GeoNetwork, which is great. All of the public sector data sets about environmental policy making should be in that spatial data platform. We're obviously doing the accessibility part of that and then joining the 2 of these systems together through APIs. So it puts us sort of ahead of the curve when it comes to thinking about FAIR. But then in other projects within my team, I mentioned the policy about address and street data. We created the One Scotland Gazetteer in Scotland, which is bringing all that mishmash of data together, standardizing it, bring it into one central place so that everybody can rely on this. The emergency services can rely on it. We rely on it to get our deliveries through the post. And that's really the reusability part of FAIR, creating standards, good data governance, good maintenance, and sustainability of really good data. And then if we think about the interoperability part of FAIR, one of the things we create within the One Scotland Gazetteer are unique property reference numbers. So every single property, both residential and commercial, has these unique identifiers. And if we insert those into any data set that contains addresses, it gives us a golden thread which we can use to join data sets together. Geospatial world has been doing this for many, many years, but it's becoming more prevalent in other areas now. we think about that final part of QFAIR, it's all about quality. How do you get people to care about quality? You have to present the data back to them and show the implications of poor data quality. And that's when we start looking at dashboards. Even though it's geospatial data, you can present geospatial data as charts and graphs and figures. But then obviously geospatial is very visual. We can look at the geometry of it. We can also look at the attribution of it and start to assess where it's perhaps deficient in certain areas. But then my big passion is bringing geospatial out of our bubble and saying, well, how can we affect the priorities of our world at the moment? So all of these issues that I've got on the screen, the cost of living crisis, vulnerabilities, inequalities, the way we plan our places, climate change, health and social care, geospatial can help with all of these things. But we've been maligned for many years as the mapping people. But really, we need to break out of our bubble and talk to data scientists like yourselves to explain why we can help things. And just my final slide here is all about the Association for Geographic Information. James and I sit on that steering group for Scotland, and we have done for many years. We hold a regular conference every February. We have a Friday night seminar series, but we also have a Knowledge Hub forum where we can start to discuss these geospatial issues and start to collaborate together, to work together to bring all of our skills together and hopefully make our world a better place, because that's fundamentally what geospatial is all about for me.
Thanks very much, Simon. Brilliant. Again, some really interesting points covered there. I think there's definitely a theme there emerging on kind of democratizing data, collaborating and bringing different data sources together. So we'll cover that in the discussion. So thanks everyone for some really interesting talks there. We'll move on to the discussion now. And I think what I got from those talks was there's some really, really exciting, positive use cases from geospatial data that some of you have highlighted. There's also some outstanding issues or problems that are apparent in working with the data or within the community. And so, for example, siloed working and siloed data, that kind of thing. So we'll try and cover those points. But just as a starter, to start off on the ground floor, and for those who are perhaps a little bit less familiar in the audience with geospatial data, aside from obviously you've given us a good background on what you're working on, but I'd just like to kind of open the floor to anyone who'd like to explain kind of what they think geospatial data covers in general and why it's exciting. If you're not using it, why would an individual or an organization think about using it? Should they be looking for use cases? Is it underutilized? Why should people be excited about it? So Simon, you got your hand up, go ahead.
So within the geospatial world, we have this sort of line that we use quite a lot. Everything happens somewhere. So theoretically, everything can be recorded and digitized somewhere. And therefore, most data and information that you come across can be made geospatial and can be analyzed and stuck on a map and interrogated and used for whatever purposes. So my challenge out there is find me some data that isn't really geospatial.
Good point, good point. Richard, do you want to come in?
I'd simply build on what Simon said there, which is that rather than geospatial data, we tend to use the term geospatially relevant data, because pretty much everything has some sort of geospatial relevance. And the trick is, particularly in an automated system, is trying to attribute that to a specific area in a way that's actually analytically useful. But that's a core part of what we do. So even just bringing in narrative data and using techniques, even ChatGPT, we've had a lot of success using that to actually infer geospatial context from narrative data. So yeah.
Brilliant, thank you, Richard. That's a very succinct explanation. I think we had Nikki and then Anna after that, so we'll go to Nikki.
Thanks, Alfie. I was just going to go to your second point of why an organization should use geospatial data. And I think quite simply, if you are trying to use data to make a point, especially with people who don't feel very confident looking at bar charts or plots, I think one of the beautiful things about geospatial data is it's really pretty and it's really impactful when you look at it. It's very easy for people to see trends, patterns, and I think that is it's a really useful tool when you are working with senior leaders who might not feel comfortable with data.
I totally agree. I think in previous discussions about geospatial data, this has come up as well. And I think there's something about looking at something mapped that for non-data and the general public, non-data users and the general public, it's really evocative and you can really understand it very quickly. So that's such a good point. Anna, would you like to jump in?
Yeah, I just wanted to say another motto that we say in geospatial world, that spatial is a special because of all the aspects, because it is the reflection of reality. It has got a lot of aspect of quality that we talk more extensively as in comparison with other type of data. Of course, maps are beautiful, but they are actually the projection of the reality. That's one thing, but also because it is ubiquitous, it's everywhere, you know, everything have got some sort of coordinate. It tell a lot about the type of activities, about the personal life of a person who is that. So the privacy concern associated with location data, that is why it is one of the sensitive data type. So it has got a lot of other challenges and potentials in comparison to other data that I wanted to raise the quality and the privacy.
Brilliant. Yeah, that's a really good point, Anna. And so I'll let James jump in, but just to flag something that would be interesting to discuss, this also came to me when I was listening to Nikki's talk as well, is that because it's often geospatial, geospatial is often international, or can be, it has kind of geopolitical implications sometimes, I think, and that's like a really interesting aspect. And you start getting kind of international ethics coming into it, as well as the standard kind of privacy and you know, data protection ethics. But we'll come to that. I think that'd be a really interesting point. But James, would you like to jump in?
Yeah, thanks, Alfie. There's a sort of hoary old aphorism that's been trouting the grounds, which is potentially apocryphal, but it's a useful metric that 80% of all information has a locational aspect. And I think if you start to think about that in your kind of conventional day-to-day stuff, that's true. The narrative stuff that Richard alluded to, we've looked at that over the years. That if you think about it, the locational stuff is just everywhere. It's littered through it. The other point I'd probably like to make is there's a risk of reductionism if we just focus on the visuals. So yes, maps are pretty, maps are eye-catching, maps are trendy, but as Anna said, you know, they don't always tell the story, or they tell a story that maybe somebody else is actually trying to peddle. So actually the critical faculty, I think, is what's missing, and that is probably one of the biggest challenges with geospatial, is its potential misuse, and particularly when you get down to give me a map. That will summarize everything. And having worked in local authorities with naive senior management who will look at a map and infer stuff and causality that doesn't exist, I think there is a slight word of caution, and that comes back to maybe the special aspects that I think Anna was referring to.
Brilliant. Thanks, James. Yeah, very, very, very valid points. And I guess, so I think from what we've said so far and the talks that we've had so far, there's a couple of points emerging that would be good to talk about in terms of the challenges of using geospatial data, or challenges to the community as well. And those would probably be the ethics side, and then from what I can gather from your talks, the kind of collaboration, dealing with silos, dealing with disparate data sources and siloed and private data sources. So if we can, we'd like to cover those 2 points, and then after that we'll move on to what sort of challenges might present to organizations if they're looking to start adopting this kind of thing, and also touch on how these resources that Simon and Richard have highlighted can be capitalized to help solve some of these problems as well. So Nikki, I'm going to pick on you, if that's okay. So you presented a really interesting use case there in terms of helping with a census abroad. I wondered if you could give your thoughts a little bit on what it's like operating, I guess, in effect, internationally across borders, and whether there are unique challenges there in using this kind of data, particularly when it's something, I guess, political. I guess censuses aren't inherently political, but they could be, and how that's been as an experience working in that field. If you could say a few words to kick us off.
Yes, it is actually really tricky. So internally displaced people are possibly some of the most vulnerable people in the entire world. And they don't, when you cross an internationally recognized border and become a refugee, you are automatically entitled to international support. Obviously, it's still a very horrible situation, but internally displaced people are reliant on their government. So these are very vulnerable people and they're in very fragile environments. And as I was saying, in Somalia, a lot of these camps are set up on private land, so they don't have permission to be there and they're not necessarily being managed and organised. And so there is a real fear that we could be putting data out there that could be used for nefarious reasons. So we have to make sure that we're being really careful. So there's a lot of kind of ethical conversations and I don't want to say regulations, that's not the word that I'm looking for, but kind of guidelines on, you know, how, if we have up-to-date satellite imagery, should we be putting that out there into the public sphere, or do we need to wait a certain amount of time where it's considered that it would be safe and it couldn't be used for those reasons? It can also be quite tricky because we work a lot. The imagery that we use, we can't really use anything that's free like Sentinel-2 or Landsat because the resolution's too coarse. We need to use high resolution imagery, and that comes from private providers. And then there are a lot of issues around that as well in terms of knowing who you're going to work with, and you set up a contract with a private provider because you want them as collaborators, but also the like data sharing agreements, being able to get imagery, you know, to be able to share it with something like the Somali government or a UN agency, that can also be quite restrictive.
Okay, thanks, Nikki. So opening this to the floor, if anyone wants to jump in. So so I don't work in geospatial data very often, at least. Occasionally I do. But to me, the questions that are coming up are from what Nikki's just said is, you know, one question is what the use of proprietary data. Why is geospatial data proprietary? Is it just for companies to make profits? Are there other reasons? And how do you handle that as a community in terms of making best use of the data that's out there and it's being kind of held back, perhaps? I mean, Nikki mentioned having individual contracts with companies, but is there a kind of wider solution to that? How do people usually handle that? Let's go Anna, and then James can jump in after.
I think James was behind me, but before me, but I will misuse
Apologies, James.
So one thing is, again, going back to the reality of data that is out there, it takes a lot of energy and staff and time to create this. That is one of the reasons that even you see in the government department, some of the department, like Department for Transport or so, they label data that they have, transport data, as the valuable asset. So that basically they say it was a cost associated with this, so we should either sell it or there is a high cost to that. So it's totally understandable. I'm not approving this, but I understand why they actually consider this as a valuable thing. And it always requires a bit of a wider, bigger picture view, the holistic view, to see the benefit. Okay, if I release this, someone else will build upon this and deliver some benefit to the society that is actually beyond the cost that originally was that, and also the power of work. Unfortunately, that's the case for most of the other government and big companies across the world. And the UK is actually one of the most leading countries in terms of making data available in terms of open data. And we have very good platform in that sense. So I just want to say, basically, that's the reason for the cost of it. However, the kind of new era of everything open source, and there are platforms or even companies that know about me more than my own government, like Google knows everywhere where I am, and you know, everything that basically flip the power. So there's a kind of a force from the other side that, okay, if you don't share it, they already have it, or they can collect it much easier than you, and so that sort of power balance need to be monitored and planned. So I won't go further, but there are some mechanisms like data taxation and so on that is possible to.
Okay, some really interesting points there, and I guess like it kind of raises the question of presumably there are some rights to kind of see what data governments or companies hold on you as well. So it's interesting that it's still kind of proprietary in that sense, even though if you wanted to, you could potentially pursue that legally. But let's move over to James. So sorry for missing out in the first place, James. You go ahead.
No problem. I guess just to kind of stress what Anna was saying, I mean, spatial data, quality spatial data, and I probably should emphasize that. So the cause célèbre here is Ordnance Survey in Great Britain, which has been around for quite a long time and has historically been the whipping boy for all the kind of open data pundits, largely because it's expensive. The problem is it's expensive to maintain, it's expensive to curate, and it's expensive to provide a quality stamp on it. So the counter flow to that is, well, why don't we just use crowdsourced OpenStreetMap? And I think there's a case for that, but the alternative take on that is the whole fake news. So essentially it depends. There's a kind of implicit presumption if you pay for something and it's quality marked that it's true. Now that may not necessarily be true, and there are quality issues with OS data as well as anything else. But I think when you put it to the acid test, if you're paying for something, you've got some comeback. If you're taking stuff for free, your comeback is, well, it's wrong. Who do I blame? And I think there's an issue there with private companies monetizing your private data. And a lot of it is down to the fact that we just give this stuff away. You know, when was the last time you ever looked at a term of service for a social media platform? You know, they're randomly harvesting all that data and selling it to all sorts of people. So I think it is a case of buyer beware. But if you pay, going back to your original question, why is it expensive? It's expensive because actually quality stuff is difficult to do and to maintain. Copernicus essentially is free to end user, but you know, the taxpayer pays for that. And that is a public good. And I don't have a problem as a taxpayer paying for a public good. But I think companies will, by their very nature in a capitalist society, want to see return on dividend. And Planet and the rest of them are good at what they do, but you know, they're commercial entities at the end of the day.
Okay, thanks, James. So Richard, I see you have your hand up. Obviously, in the context of what you've produced with Blue Globe, and it'd be good to touch on Inspire as well, that Simon's mentioned. Perhaps you'd like to say a few points about that as well afterwards in this context, but go ahead.
Yep, just very quickly, and really following on from what James is saying, you know, we are a commercial operation, but we see public good as being something that basically is something we can derive value from, but we also need to step up to the mark and actually add value to that for the public. You know, it's the old open, very much coming from the open source background there. You know, you made the very good point that OS is a whipping boy for open source community, and guilty as charged, by the way. But they have an anachronistic licensing model. You know, you can start with the argument that they're selling data that's been produced with taxpayers' money and then privatized. Probably not one to go into at the moment, but I've had a lot of dealings with OS, and their licensing model is out of the 1980s. If they had a more flexible, adaptive, and scalable licensing model, it would make all of our lives much, much easier. As it is, in certain areas, they are in danger of becoming irrelevant. One of the things we do very strongly is see what we can infer in terms of data quality from combinatorial approaches to data sets, not necessarily at a high resolution. So we can combine OpenStreetMap data with OS data, with ONS data, and we can start pulling all that together, and actually we can see how it cross-validates each other. That actually massively improves the quality of what we can do in terms of providing it as an open access platform. When it comes to the commercial data side, so Planet was used as an example, and they're a very good one, Planet or Maxar or you know, any of a wide range of either commercial data providers or organizations that you're working with who actually have their own private data that they want to quite reasonably to keep private. So you have your cross-validated open source data. You've got the data budgets, which are costly, and the data access, which is even more costly for commercial data sets, but you can actually with a common computational framework, you can actually munge them all together, and actually then you can slice and dice access according to client, market, sector, application, whatever you like. It means you can constrain your use of commercial data to where it's really needed rather than having to rely on it, at which point basically your costs go through the roof and you don't deliver anything.
Okay, thanks, Richard. So I'd like to talk a bit more on the point of kind of this data access. Should we, and Simon, I know you are kind of an advocate for this as well, in terms of joining up the dots in terms of making data available and combining it and making it available to the community. So perhaps you could say a little bit more about that. What is the community doing now? Or when I say community, I just mean geospatial data practitioners and users. What are they doing now to make best use of these different kind of disparate sources of data, and what could we be doing in the future to improve on that?
Okay, so really, I think what we're talking about there is data standards and data governance and these sorts of things. And I was going to mention something that there's a direct read across between that conversation about proprietary data and open source data and policy and legislation. When policy and legislation is created without due funding, or when strategies are created without resources, then they rarely deliver what they're intended to deliver. There's a lot of talk at the moment since COVID about how important data is for making important decisions about the way we live our lives, but there aren't the resources being put into doing things well. So that conversation is beginning to happen a lot more. There's a data standards community growing within Scotland, within the public sector. Again, that phrase data standards, it gets bandied around quite a lot, but we really need to break that down into what people mean. Quite often they're talking about the semantics when they talk about data standards, but the stuff I was presenting in my 4-minute pitch is about computer-to-computer interaction, API services, good metadata online that you can find easily. Because if you can't find it, you can't do anything with it. So that there needs to be a real change in the thought process about how we are implementing the policies of the government of the day to deliver what they set out to do, and data helps with that, but it's got to be funded well.
Okay, thanks. James, do you want to come in? After that, I have a question for Nikki as well.
Yeah, so I guess I should probably just reply to kind of Richard. I'm not by any means an apologist for OS, having spent quite a lot of time arguing exactly those licensing points with them. But going back to Simon's point, the standards and interoperability are key. That comes back partly to data quality stuff. I sit on the UK British Standards Board that is in charge of defining some of those geospatial standards. There is a geospatial registry that's run by the Geospatial Commission, which is in trying to promote good practice, all the stuff that Simon mentioned, metadata and the rest of it. If you're in Scotland, there is a spatial metadata catalogue where you can go and discover stuff, but it's by no means exhaustive. And it does come back to what do we mean by core geospatial stuff. A lot of that, I don't want to say dark web, but it is pretty much dark web stuff that actually sits there locked up in personal stores, in small enterprises. It's implicitly geospatial, but it's never released, and that's where a lot of the value lies. Some of that might get unlocked at some future point, but by and large, the kind of formal geospatial stuff is the stuff that people know because there's a commercial market for it. It's probably the stuff that's sitting in your organization, has all that stuff locked into it, that actually could enable you to do proper spatial analysis, proper spatial decision making, that actually would be to your company and your own benefit. That's the stuff that's locked up, and it's the stuff that is difficult to connect because it's unstructured. So unstructured geospatial data, I guess, is my kind of headline for this bit, is that's the stuff that where a potential lot of value lies, but it's actually very difficult to unlock. Well, there are tools emerging that will help do that, but I think you have to recognize that is an asset you have and you're sitting on, And if you're not aware of it, well, you're never going to unlock it.
Okay, thanks, James. So we have about 15 minutes left before we move to Q&A. So if it's okay, I'd like to slightly move on to an adjacent topic. So we talked a little bit about data access, the structures that are in place for that. We touched a little bit on the ethics. Another interesting point that would be good to discuss, and I think perhaps many people in the audience might be interested in hearing about, is what kind of skills are required to work on this data, and what skills are required within the practitioner community? Are they abundant? Are they scarce? And where's the future headed in that sense? So I'm just going to pick on Nikki and then Anna after that, and then I'll open the floor to anyone else who. Nikki, if you'd like to say a bit, like, how did you end up working in geospatial data? What skills do you have to develop, and what would someone who is coming into the field need to develop?
So my background is probably a little bit weird and convoluted. So actually, I do have a geology degree and then a PhD in planetary sciences, and then transitioned into being a data scientist who then started focusing on geospatial things. And I guess I have a vague interest in all of those things that mesh that together. And I also said that I like to look at pretty images, and you get to do that a lot with geospatial stuff. I think one of the things that you maybe, as a data scientist who's maybe working on structured data sets, one of the things that you don't necessarily appreciate when you start working, so what I do particularly is looking at machine learning and geospatial data, there's an element of data engineering that you end up having to work with, because what we do is really computer intense, is resource intensive, and so you need to be able to talk to data engineers about, you know, GPU, memory, these kind of things that you don't necessarily have to think about with other data sources. And I think this is also, it can be a point of contention. For example, what we create at the data science campus, our ambition is to embed that in other organizations, but what we're effectively saying is that we want you to overhaul your IT. A lot of IT, especially in the public sector, is really locked down, and if you go to them and say, I want to use our studio, they have a mild panic. So if you go to them and say, actually, what I need to be able to do is I need to be able to run Python, I need GPU access, and I need to be able to do all these things in a cloud-based environment, that's not what they do on a day-to-day basis, and that's going to be, you know, you're almost asking them to upskill their IT department. And then you also need that data engineer support. You're probably going to be one person in an organization trying to push this forward, so you almost have to have someone who has a lot of those hats on, and I think that can be a massive stumbling block to getting things pushed forward, because it is such a big ask. But I would also say that there are lots of other aspects of geospatial data that are kind of easier, don't require that kind of like data engineering technical knowledge to kind of start getting your feet wet with.
That's really interesting. And I think it kind of chimes in with, I think at the moment there is in general like a push towards kind of modernizing and updating practices within government departments. I mean, there's a big push for reproducible analytical pipelines and things like that, which kind of chimes in with the kind of sets of tools and skills that you were describing that are useful for your work. Anna, would you like to come in on this? And so anything to add there? And
it's very similar. It covers a lot of that. I just wanted to just very briefly say, well, I am a geospatial data scientist. My job title is Professor of Geospatial Data Science, and that has got like three components of the statistics, computer science, and geography, by the kind of broader sense. Well, regardless of what is your degree title says, good understanding of these three are very good for doing data analytics side. Of course, if you want to collect data, that sort of surveying and so on. And if any of these are missing, there is a problem. So I've seen a lot of computer scientists only that do not have their background in geography, and they just look at geography as a type of data, and not knowing anything about projection and coordinate system, resulting getting a result which is wrong. And the funny part is your code is not giving you a bug. it works. It's just the wrong answer you get. And the other way around, a lot of geographers with a very good understanding of geography, but because they don't have those capabilities, they end up using some of the tools that are already existing, and so they can't really leverage into it. So I just wanted to say the combination of at least 2 or 3 of these are quite essential for data science. Of course, for collection, geomatic, and that sort of area is very different. So I'll pass over to Simon to cover the rest of these.
Thanks, Anna. It's a really, really interesting point, and I guess not necessarily unique to other areas of data science as well. Often you need that domain expertise either from the data scientist or from a domain expert in the project. So, sorry, go ahead, Simon.
So yeah, I'm going to give an answer which isn't really to do with technology at all. It's based on my role, really. I call myself a data and engagement manager, but sometimes I call myself a data translator, a data evangelist. And really, it's all about communicating what we do in different ways to different audiences to demystify it. And that's probably generic to most data skills, because we often get ignored, maligned. People just don't understand what we're talking about when we use words like geospatial and spatial, and when we start using acronyms. So I've started dropping those sorts of words and stopping having those discussions when I speak to senior people and policy people that can really make a difference, because they're not helpful. So it's a key thing that we all need to consider as data specialists. I would say the way that we communicate what we bring to the party. It's massively important, and it gets forgotten about all the time.
Anyone like to add anything? Very good point, Simon. So what's the kind of current kind of market supply for people with these skills then, for these kind of expertise? Are these people in demand? Is there an abundance of them? Is there, so Simon's shaking his head that they're in demand. Is that fair to say?
They're massively in demand everywhere. When you consider what we've been saying before, all data has a geospatial component, but we haven't got people to create it and analyze it. That's a real problem. And we've just seen that the latest GIS course in Newcastle has been ditched fairly recently. So it's a real concern. Our planners are coming out of their planning degrees without ever having touched a GIS in some places, which is worrying. So I've been talking to the data lab on and off for 2 years about collaborating with that data science community so we can sort of spread this knowledge more widely, because we need more people understanding why geospatial is so important, and we can grow. We've brought people into our spatial team that are developers, software developers, and they pick up spatial really quickly. So that you don't necessarily need to do the formal courses. There's courses online where you can learn this stuff, and people pick it up very, very quickly if they have a data background. So that's reassuring.
Brilliant. So some kind of synergy and increased overlap between just the general data scientist community and kind of geospatial would be beneficial in this sense. Sounds like you've been pushing for it for a while as well, which sounds like a good initiative. Richard, do you want to jump in?
No, I was just going to say that the other way to look at that, when you look at the skills shortage in the industry, but also being able to make the information accessible to people who have no background in this whatsoever, is what we're trying to do is provide an abstraction layer for all data into a common framework. The idea being then we can build a whole range of tools, open and commercial tools on top of that allow people with no background beyond being able to use a web browser to actually access and use the information. That is don't mean to underestimate the severity of that challenge. But then the other thing that was mentioned earlier was actually, how do you unlock the data that's embedded within an organization? And one of the things we've already done with people like Nature Scott is to actually say, throw us some of your background data, your reports, we'll throw it into our system. And I'm literally using the word throw it into our system, and let's see what it can actually produce in terms of patterns, metrics, trends and dynamics from that when it's combined with the other data. All they've got to do is basically say, here's our data, and then let it do its work. You're always monitoring that, you're always conditioning that, you're always looking to do QA on that. But I think that's the flip side of it, is trying to make the whole thing more accessible.
So it's like that key point again of kind of increasing the value by combining it with other data sources. James, do you want to come in?
Yes, sure. I just want to pick up on the kind of geospatial skills. So for awareness, there's just been 2 recent skill surveys, both done by AGI. One in the kind of AGI in London, which covers kind of England and Wales, and a Scottish equivalent. Both those reports are slightly out of phase, but essentially there may be regional differences in the kind of skills. I think the English one is worth a review and a brief look at if you're interested in this, because it does highlight where that kind of overlap between traditional GI, GIS, and the kind of new breed data scientists, which I must confess I do have some reservations about, because the geospatial folk have been doing data science, even when it wasn't called data science, for at least the last 50 years. So, but anyway, the kind of epistemology of kind of nomenclature apart, I think there's sufficient evidence out there to say that there is a range of skills that are still required. You don't need to be a data scientist to do geospatial stuff. You don't need to be a geospatial person to do data science specifically, but the overlap obviously has a lot of intersections, and there are, coming back to Anna's point about is spatial special, I kind of vacillate. In 30 years I've worked in the sector, I kind of vacillate between whether it is special or whether it's not. Sometimes I think it's just another data type, get over it, guys, stop hyping geo as special. And then on other occasions I think, well, actually maybe there is something there, maybe we should kind of egg it up. The problem, a lot of the geospatial problem is it's a definitional nomenclature problem, and a lot of people just don't get it. As Simon said, they switch off. You know, location maybe acts as a proxy for geospatial. People kind of understand location, they don't really get geospatial, and geospatial people themselves struggle to give a clear definition of what that is. So you can imagine, if you're naive and have no prior exposure, what you may make of that. Regardless of what we call it, there's data analysis stuff that needs doing with things that are kind of space, location, geospatial related. There's plenty of skills out there, and there's plenty of kind of opportunities. The whole new breed of SMEs. You only have to look at Edinburgh in terms of incubator. It seems like every other week you're just tripping over a new startup based around Earth observation. So outside of London, Edinburgh is the kind of capital for that in the UK. So if you're on the call and you're listening and you want to get into kind of geospatial, there are plenty of firms out there to go to.
Brilliant. Thank you very much, James. And on that note, we are now due to jump into Q&A. So thanks for a really interesting discussion. I'm going to go through the Q&As. I'll try and get through as many as possible. So apologies if I don't get to yours, but I will try. If you're answering, panelists, if you could try and keep it succinct, if that's possible, so that we can get through as many as we can. So the first one is from EUP. I'm sorry if I pronounced that incorrectly. And they say, I guess any OS-based data has an open source license, presumably. So what about usability of other data sources? Is there any GDPR or licensing limits there? And can I use data I see around? Who's the commissioner or regulator in that field? Is in general or in Scotland? Would anyone like to jump in with that? So how's open source data regulated essentially, if at all? No takers? Okay.
Just repeat that. How is open source data
regulated? Is there a regulator in the field?
It isn't.
I think that the short answer is it's self-regulated. I mean, that comes back to the quality aspects. So Ordnance Survey data, a lot of OS data is probably worth, even though we've kind of beat on them up slightly. The OS Data Hub has quite a lot of very valuable open source data that they maintain. Admittedly, they maintain it at taxpayers' expense indirectly, but it's open. So you're free to go. You're free to apply for a 1-year developer license, which will give you access to the paid stuff for free if you want to experiment. There's also something called Geovation, which is run by Registers of Scotland in Scotland. Talk to them if you've got a startup idea and you're interested, and your problem is I can't get around the licensing constraints that, or I want to sidestep the licensing constraints while I proof of concept something. That is perfectly possible. So I wouldn't let that be an impediment. Open source stuff is a bit of a wild west, because that comes back to the quality thing, and there are typical licenses, so open database licenses and stuff that apply. So most of the open stuff that's out there will have some sort of licensing, whether it's very permissive or whether it's quite constrained. You just need to pay attention to the licensing, and that probably is a heads up. If you can't find a license, probably worry, because it means either it's been raided from somewhere else, or they haven't given it any thought, and you could come a cropper somewhere down the line because you're infringing somebody else's IP on.
Brilliant, thanks, James. And I would add on the point of GDPR. I think there's a very specific definition of what types of data GDPR cover, and it's to do whether it's personal identifiable data for the most part. So I think that would be regardless of the data type. The definition would still be the same for whether it's covered under GDPR. Joanna, so I can see panelists have been answering questions via text as well, so thank you for that. There's a few that I'd like to get to if we can anyway, but for Joanna says, now that satellite imagery is more prevalent and available, are there overlaps in the techniques developing between the analysis of images and more traditional map data? So I'm not sure personally what traditional map data entails there, but I guess are certain analysis techniques from one type of geospatial data being applied to other types of geospatial data? I think is a more general question perhaps that one of you could answer, regardless if that's satellite data or not. I saw Richard nodding, so I'm going to give Richard a chance. James, sorry. Go ahead, Richard.
Oh, just very briefly, that's a fundamental part of what we and others are trying to do. It's I said in my talk, you can use multi-source data or overlapping data sets to reinforce each other where they agree. You can use them to contradict each other where they disagree, and then you can start looking for actually where the truth lies in it, and you can make inference from the combinatorial stuff that adds value to the whole to the whole model. James keeps talking about the quality aspect of open source data. This is one of the ways we try and address that, is by actually munging everything together and looking for those patterns and looking for the red flags where they don't actually reinforce each other, and then we can actually either reject data or we can improve our algorithms and in terms of how we process and how we assign trust to it. So the short answer is yes, and we aren't the only ones working in that area. Lots of people are working on exactly that problem.
Brilliant, thanks, Richard. That's a great answer. So I'll let Simon jump in, but then just in the last few minutes after that, Anna, I see you've answered a really interesting question about how we ensure that security and privacy of geospatial data is upheld. You've put a text answer, but for those that aren't reading the Q&A, it'd be good to go over that. But quickly, Simon, if you want to come in, and then we'll go to Anna.
It was just going to be to make the point that most people who've done a GIS degree will normally look at methodologies around analysing satellite imagery, and we call it raster data in the GIS world. But it's a standard sort of component of most GIS courses. I think the thing that is changing is the use of AI now to do these, and the automation of these kind of analyses, and we're going to see a massive growth of that in the near future, no doubt.
Brilliant. Yeah, so we didn't have much time to cover that, but that's a really, really interesting topic in itself, how AI is kind of progressing in the field. In the last few minutes, oh, sorry, Anna, did you have a point there?
No, I just wanted to.
Yeah. Okay, well, I have a question for you, which you've already answered, so apologies. But for those that haven't read the Q&A chat, there was an anonymous question which said, how do we ensure that security and privacy of geospatial data is upheld? For example, the leaking of data through breaches. And you've given quite an interesting answer. I wonder if you could kind of elaborate that
Yeah, I think we should separate privacy and security, although they are very, very close to each other in the concept. But protecting privacy is a very interesting, challenging thing, because location data is very, very rich. So protecting any information coming out of it is very difficult. For example, we have a lot of privacy protection model in other data like differential privacy and so on, where you have a privacy budget that you distribute and basically make everything a little noisy and you're fine with the model that you have. It's not as simple as I described, but for location data, that's not going to work that well because first of all, location is everywhere. You can link a lot of other things together. And there are papers, actually very famous paper in Nature that actually said if you have 4 points in a trajectory, even in a kind of a crowd element, you can distinguish people. It's not identifiable, but still distinguishable. That means a bit of a scary thing. There are new models that have developed based on, clocking and, other things that look at data privacy protection. But security, as far as I'm aware, most of the security practices and models that exist are very good are as good as they are for geospatial data. So it's not that exceptional challenge they bring to us.
Thanks, Anna. Brilliant. And so sorry, Jim, I'm just going to ask Nikki very quickly because I feel like this might be a relevant point for when the project you were describing where you're working on developing a census. I mean, that could be very sensitive data potentially. It's information on people's circumstances at the moment. So how did this play in when you were developing that? How did security and privacy concerns weigh in that sense?
I would say that this is something that the ONS is obviously very good at. Like the ONS is responsible for the census in UK, in England and Wales, sorry. So there's a lot of expertise there, and we obviously go through a lot of ethics assessments. The work that we do doesn't identify individuals; it can identify groups of people technically, although we are actually given those locations. But I think just to be reassuring, if we were ever working with data that would be personally identifiable, we would be doing that in a really secure environment. In the same way that people would be working with the actual census data, we would work in a similarly as secure environment to make sure that we don't have security breaches.
Brilliant. Really, really exciting stuff. So I think we're going to leave it there. So thank you so much to all of our panelists. You've been brilliant, really interesting discussion. We hope you'll come back and join us in future events. And also, I'd like to say for those in the audience that aren't already members of the Data Lab community, I would encourage you to sign up. You can sign up with the QR code there on screen, or you can Google the Data Lab community. There's lots of interesting resources there. You can talk to people about your data science problems. You can get mentoring from experts in the field. And there's a ton of resources on there that are really useful. There's job postings and things like that as well. So if you're not a member, consider joining up and coming along to future events like this. So thanks again to our brilliant panelists. It's been amazing, and thank you for your expertise and your time. And thanks for everyone for attending, and we'll wrap that up.
Thanks all. Bye.
Bye.